Hello again, and welcome back to 3-Minute Intellectual. Today we're going to be talking about physics. You've already clicked away, haven't you? If not, don't click away just yet. Chances are you're more of a physicist than you think. I bet you've heard people say things like, objects in motion stay in motion, or every action has an equal and opposite reaction. These common phrases that we hear all the time on TV or in movies or even in casual conversation are actually describing complex physical laws that govern our entire universe. So let's get physical and talk about Newton's laws of motion. That pun actually works on several levels. You know, like physics, Olivia Newton-John, right? I cannot believe I just said that. Just start the clock. Law number 1. Here's the equation. I have no idea what any of that means. Okay, no more equations. Newton's first law states that an object at rest will stay at rest, and an object in motion will stay in motion in the same direction and with the same velocity unless acted upon by an unbalanced force. Basically, an object is going to keep doing whatever it is it's already doing unless acted upon by some stronger external force. If you've ever been on a skateboard, chances are you've had the pleasure of running into a tiny rock that somehow stops your board cold while you go flying headlong onto the sidewalk. You and your skateboard are in motion until an unbalanced force, the rock, acts upon the wheels of your board, stopping it. Since you and your board are not connected, you continue moving in the same direction and with the same velocity until, of course, you too come to a stop when the sidewalk exerts an unbalanced force on your face. If there were no rocks, no gravity, no air resistance, no friction between your wheels and the sidewalk, you and your skateboard would move in the same direction with the same velocity forever. Law number 2. Newton's second law describes the interaction between force, mass, and acceleration. I know I said no more equations, but I promise this one is simple. Force equals mass times acceleration. Put simply, if you increase the force on an object, acceleration will increase, and if you increase the mass of an object, acceleration will decrease. Heavier something is, the more force it takes to move it. Faster you want something to go, the more force you have to apply. This is all very handy for understanding how the universe moves, but it's really not that great for sounding smart on a Tinder date. Which brings us to rule number 3. Newton's third law states that all forces between objects are equal in magnitude and opposite in direction. Remember that whole every action has an equal and opposite reaction thing? That is Newton's third law of motion. Whenever two objects interact in any way, they exert forces on each other. Even when you're just standing there, you are exerting a downward force on the ground while the ground simultaneously exerts an upward force on your feet. Forces always come in pairs, and the size of one force is always equal to the size of the second force, and the direction of the first force is always opposite the direction of the second force. Think of swimming. I'm pushing water backwards with my hands and feet, so the water is pushing with equal force and in the opposite direction. I move forward at the same speed I push the water back. Newton's first law, objects at rest stay at rest, objects in motion stay in motion. Newton's second law, force equals mass times acceleration. And Newton's third law, every action has an equal and opposite reaction. Thank you for watching 3-Minute Intellectual. I hope you learned a little bit today. Now go learn a lot.